All right, and then we are gonna go ahead and start today's lessons. We are gonna be going over, so we're gonna start going over progressively more and more complicated things. But for today, we're going to be talking about for loops. We've got, let me think, while loops. We have a little bit of recursion, I think, and we have arrays as well. So we're gonna do as we tried to do before, and we have 4 topics. All right, so let's go ahead and get started with for loops and scope and recursion. So, if you're familiar with other programming languages, you've definitely heard of the for loop before. It's pretty ubiquitous. Um, but basically, to break down the for loop into 3 segments in Java, we first of all, we declare a for loop by saying for, and then we have parentheses, and inside it, we have like 3 different statements. And so the first statement is always going to be your index variable, or like what variable you want to declare and initialize at the beginning of the loop. The second one is the exit conditional, which is going to be a comparison. It'll give you a false or true, and it'll say, should I keep looping or should I stop looping? That's what the exit conditional is. And an iteration is a small little statement that you can have run every single time one loop finishes. And then you have curly brackets and then you have your body, and that code will be looped over and over again. And what do I mean by looped? I mean that the code gets called over and over again. So if you want, like, for example, 4 blocks of code to be run a certain amount of times, that's how you can do it. You can put it in the for loop. And on the bottom here, we have what is the most common and most traditional for loop. In Java, there's a bunch of ways you can write a for loop you can almost say they're unconventional, but this is basically 95% of for loops you're going to see in code are going to be like this in some way or another. So the first part is the index variable, right? In this case, it's convention to say integer I is equal to 0. I standing for index in this case. Okay, so, and remember, because we've talked about this before with like the strings and whatnot, computers start counting from 0. So just remember that. And in the second statement, as you can see between the 2 semicolons, we have I is less than 5. So what does that mean? It means if we started off with I equals 0, then I less than 5 is true. So it will keep looping. Then we're going to move on to the third statement, I++. And this is some new syntax that you guys haven't seen yet, unless you, again, familiar with other programming languages. But I++ simply means we're going to add one to the variable. So if I was 0 before, it will then become 1. If it was 1, it'll become 2. Kind of makes sense, right? And so what that means is this will loop 5 times, because I is going to start at 0, and then it'll check, say, oh, okay, I is less than 5, so I'm going to keep running, and I'm going to increment I by 1. And then I'm going to go back again. 1 is less than 5, and it becomes 2, et cetera, until I becomes 5, the conditional is no longer true, because 5 is not less than 5, right? So it's going to break out, and it's going to keep executing code, and it's going to stop looping. And then inside the loop, we have a system.out.println, which is simply prints out the variable I. And oftentimes when we're like writing algorithms, processes, or whatever you're trying to do, that variable is going to be very useful for you to help you do some things. Okay. So here's an example of, oh, actually this is scope already. How about, let's go ahead and run this code so that you guys can get some sort of sensible idea of how this works. Right. So you guys probably remember this project. I'm just probably going to keep reusing it over and over again. But for now, I'm just going to go ahead and make a method. I can zoom in a little bit. And then and then we're going to do this, right? We're going to go ahead and call this static method in the main clause, right? So remember, methods are chunks of code we can reuse, and in the main function, we're just going to be calling print loop, right? And we're going to declare our loop. First of all, we're going to type for, and we'll do parentheses. And remember, we have to do our 3 statements, okay? So our first statement is our declaration. So I'm going to say integer I equals 0, and then I is less than, let's say, let's go and use a parameter. Let's say, let's just have an integer num. I'm going to say we're going to loop this 6 times, okay? So as you can see, you don't necessarily have to use, you don't have to hard code a number. You can use a variable as well. And then we're going to say I++. Okay, and we're going to do curly brackets. So does anybody know what, like a general idea of what is going to be printed out? You guys can say in the chat. So this is going to call, this is going to loop several times, right, up until the exit conditional. It's going to print out I. Okay. Well, seems like a lot of people are not certain. If I were to run this code, it's going to print out several numbers from 0 to 5, right? And the reason why 6 is never, yeah, that's my summary. The reason why 6 is never printed out is because the conditional check is before the body itself is run. So 6 is less than 6, or 6 isn't less than 6. That's why 6 isn't printed out, even though we stop at 6, you know? And just to show you how loops can be pretty flexible depending how you want to do stuff, we can start at 2 if you want to, you know. Let's say you wanted to go backwards. You can do this. While I is greater than 0, you can do minus minus. Right, see how we're counting down. If you wanted to go up by steps, you can of course do, this is a different form of syntax, right? It combines, I don't think I've gone over this before, but I plus equals 2 is the exact same as I is now equal to I plus 2, okay, or 3, et cetera, et cetera. It's just shorthand form. And similarly, I plus plus is just I plus equals 1, which is also I is equal to I plus 1. So Java's got a bunch of shorthands for this kind of stuff. And the same applies, actually, same applies for division and subtraction and multiplication, except division and multiplication, I don't think has this one. All right, we're going to run this real quick, and then we're going to go back to the slides. There you go, 0, 2, 4, times by 2 each time. And if you guys, there's like a certain plague for people who don't code much, is they accidentally code an infinite loop. What I might mean by an infinite loop? An infinite loop is one where the exit conditional will never become false, and the loop will run forever and ever, and your code basically is stuck forever. And modern computer programming languages will know to stop. Okay, so like for example, if I say if I is shoot, how can I make this an infinite loop? Yeah, actually, you know what? If I just put true in here, if I put a I just put true in here, as you can see, it's printing out infinitely, and my computer is starting. Okay, yeah, like IntelliJ can't even keep up. But infinite loops have a use case, and they also don't have a use case. And just so you know, if you really want to make an infinite loop, this is completely valid code. All right, let's go ahead and go back to the slides. That's enough of this. All right, okay. So we're going to talk a little bit about scope now. As you guys have probably noticed, in Java, we use a lot of curly brackets, okay? And those curly brackets actually have a pretty good meaning. And also, yeah, does everyone understand how the loop goes so far? I hope I'm not going too fast.
I also wrote up, if people don't understand, I wrote up a short, like, it not in a loop so that people could see.
Oh, where is it?
No, it's not on the slides. Here,
Okay.
I'm going to stop you.
I'm going to stop my share. Okay. Oh, okay, all right.
So these two, the for loop and this is basically what the for loop's doing. If you didn't, so this runs once at the beginning, and then it checks the conditional each time. So I is 0 less than 5, and then it does the print, and then it iterates. And then it does that again until whatever this is not true.
Yep, that's about right. Thank you, Grady. That's a really good way to put it. All right. So I hope everyone understands it now, right? Again, if you guys don't understand, you can just say DM either Daniel, me, or Grady. Actually, preferably Grady or Daniel, because we can move on to the presentation. All right. So the curly brackets, in Java specifically, we call every single time a curly bracket is used, where you have one that points to the right and one that points to the left, we call it a block. Okay, and every block has its own individual scope. And what do I mean by that? When I say scope, I mean like what kind of variables code inside that block can see. Okay, so here we have a method. Okay, so because the method uses curly brackets, right? We can say, like, I can use a laser pointer, right? Yeah. Because we got curly brackets, right? We're forming a block here, and we've got a bunch of variables and a bunch of code inside, right? Now, how do we know which variables are can be seen by others? Because if every single block of code, or every single line of code can see every single variable ever initialized, number one, on large projects, you're gonna have compounding variable names where like variable names are the same and you have to do some really ugly stuff. Or it can impose really big security issues, okay? And if you're ever familiar with web development, that can be a bit of a slight issue. Okay, but so scope is something very important to understand, and it will also help you write better code. So I hope you guys can understand this pretty well by the end of this. Okay, I'm going to stop blabbering on. Let's actually get to what this means. First of all, every method has a variable, right? Integer num. So that means technically that we have an integer inside this method block where my pointer is, where it's being initialized and declared, right? So that variable belongs to the scope of this method block. And every single line of code within the curly brackets of the method will be able to use and see that variable, okay? But if you have another variable next to add loop, even if they're in the same class, they can't see this parameter integer num. And I'll show you guys more practical examples of that later. I'll finish with this first. And in here, we have another variable string h is equal to hello. So this is initialized and declare inside add loop, right? Inside the block of add loop. So again, it belongs to the scope of add loop. Oops. And now we got a for statement, right? Integer I is equal to 0, I is less than 5. Integer I is outside of the for loops block, right? You see how we have another block here? So integer I here actually belongs to the method's scope. So if I had another system out.println after this, I can print on I and I won't have any errors, okay? But as you can see in here, we have another integer here, right? A is visible in the for loop after this line, right? So that's why we can say system.out.println h plus a plus num, okay? But because now we have a scope inside a scope, right? We have a block inside a block. That means if I put a system.out.println outside of this for loop, if I put a system.out.println outside of this for loop, it cannot access this a variable, okay? It can access num, it can access h, but it cannot access a because a is inside a scope that it's not in, okay? Now, that might feel that kind of doesn't make any sense right now because we're just looking at some text. So I think some practical examples will definitely help for this. So as you can probably see in the various code that we've written during class, right? We have some we've made methods already, right? And like I mentioned, hold on, let me just get this into a usable state. Right. So we're going to use a print loop function here again as an example, right? And we're just going to just for the sake of example. So again, integer num is within the scope or the block of this, right? So if I wanted to say system.out.println, println num, look, no errors. If I say this, again, no errors because num belongs to this block, which belongs to this block, which means I can see this, okay? And I'm gonna start using the word, I'm gonna stop using the word block and I'm gonna start using the word scope more. But we have integer a in here, which is inside the scope of this for loop, right? If I went outside of the scope of this for loop here and I try to print out a, I can see I get an error. It says cannot resolve symbol a because it is out, because a is inside the scope, inside a scope that this is not, okay? Similarly, I have another method here, right? We made add one a while ago and it has a parameter integer number. If I want, because this is a different scope from this, right? You can see how they're kind of the same level, like this whole class has a scope, but these are technically in different scopes of the same quote level. I cannot print out number, okay, see? But, and this is something we're gonna touch on later, but I'm just gonna really quickly show it now. I can actually declare a variable outside of methods inside the scope of the class, right, the entire thing itself. So I can say foo was free. I can actually use foo anywhere in this class I want. I can use it here. Oh, that's new. All right, I have to call it static, right? Yeah, there we go. What the heck? I can call foo here. That's completely valid. I can call it here, and I can even call it inside my main function. Okay, so I hope the idea of scope kind of makes sense. Because IDEs are able to tell you if a variable is in or outside of a scope, it'll be obvious. An error will come up. When we do more practice, scope hopefully will come intuitively. Okay, and the idea of blocks in Java is not exclusive to Java. There are many other programming languages who that are similar like this. If you ever seen the parentheses and the indent in Python, or sorry, colon and the indent in Python, that's kind of like a block. Something interesting in programming language like JavaScript is for and ifs don't actually make a block. So, but in the context of Java, every single time you see curly braces, just automatically assume that it creates a new scope. Okay. Let me go back to slides. So do I have any questions about scope so far? Okay. All right. And now that we're done with scope, we're gonna do something a little bit, this one's gonna be a little bit hard to think about. Recursive for some people doesn't come intuitively. But when it comes to doing an action over and over again in programming, I guess you can say in computer science, there's two main ways you can do it. You can do recursively or you can do iteratively. And just to put it simply, recursive means the code will call itself over and over again and will stop calling itself when the end condition meets. Iterative is when we keep track of a variable, like a kind of counter, you know, or in, well, what we've seen so far, an index, and then it'll numerate or iterate the that counter variable 1, 2, 3, and it'll watch for that to stop. Okay, and depending on the application, recursive algorithms can sometimes be more elegant than iterative algorithms. Iterative algorithms can sometimes be more elegant than recursive, and sometimes when you scale up, recursive is more I don't know how to say it. It takes more resources to run it, but that's in practicality out of the scope of a robotics team that goes into industry and a lot more scaled up stuff. But here we've got two examples of recursion versus iteration, and all it does here is that it's going to print out a number from 1 to 5. Okay, or not 1 to 5. Or actually, yeah, I see. Add until 5. Okay, so we're gonna start with our classic loop here, right? So let's say if I pass in 0, we're gonna keep going up until 5, right? So integer I is equal to number, while I is less than 5, we're gonna add I. So we're gonna say 0, 1, 2, 3, 4, 5. Makes sense, right? Because you're just looping 5 times. Now this recursive thing, there's some things that we kind of see that are similar, right? First of all, we have numbers less than 5. Okay, we kind of have that comparison less than 5 in both of them. They share that. And you know, if the loop doesn't run, we just return -1. And then, but the key difference is how we run the code over and over again. Because we have a for statement in the iterative, Java automatically does it for us, and we explicitly state that it goes to I is less than 5. Here, we say number is equal to, if number is still less than 5, we're going to print on the number, right? So if it's 0, we print out 0. Then we say number is now equal to add until 5, number plus 1. Okay, and what that's going to happen is it's going to call itself. Okay, so let's just think about this. Okay, let's just imagine number 0. Okay, so on our first run, now we're going to call ourselves again, and we're going to pass in 1 instead. So we're going to now enter the number equal to 1. 1 is less than 5. Print out 1, and then number. Now we're going to call ourselves again and do 1 plus 1. So 2, do it again. 3, do it again. 4, and we're going to 5. 5, we're not going to call this anymore, and then we're going to turn -1. Oops, sorry. And then we're going to return number, and the whole thing is going to pop back out, and then the recursion is finished. Okay, and let's go ahead and try running these. Let's go ahead and try running this code. Give me a second. I'm going to be copying and pasting this into my IDE right now. There we go. All right, we're going to go ahead and run add until 5 first. Okay. We're going to start at 1 or 2. Okay, just to add a little bit of variability in it, and this should print out. Let's finish building. Oh, did we make a mistake here? We did. I think we need to print an I. There you go. 2, 3, 4. Right. Now we're going to call the recursive one, and then I'm going to go and comment this out. Right, and see, it does the exact same thing, 2, 3, 4, but here it's calling itself, and then here it's just using a for loop, okay? And there are very specific use cases for a recursion and a iterative algorithm. And if I have to be totally honest, recursion isn't used super often. But if you're trying to learn, for example, if you're like in a college class, they'll probably ask you to like, for example, list all the files inside a directory where there's more directories inside it. That's where recursion algorithm might work, or some sort of, you have to do some complex data structure. But just to be in the scope of our robotics team, I don't think we've used recursion very much. Okay. Well, by the way, the shortcut for commenting out is Control/. Very useful. All right, let's go back to slides. So this isn't going to be super applicable to everybody, but it's a good to know. Okay. All right. We're done with that topic, and actually, I think I had a classwork assigned for loops. Let me go and double check that real quick. 331. Took a little bit long. It's okay. I can go a little bit faster now to explain a lot of concepts. Yeah, okay, I got a classwork question for us. All right. Actually, I was gonna have you guys. Let me think about this really quickly. 31. Okay, I think it's okay if we. All right. I'm going to give you guys 10 minutes. If you guys have your IDEs ready, we're going to go ahead and try to do this practice right now. And you have to write a for loop that produces this output. And I know in the practice it says that you print it out on one line. It's okay, just use print line for now on multiple lines. And we're gonna do the same thing we did a while ago, where you're just gonna respond. You're gonna paste your code into the thread. So I'm gonna give you guys time until 3:40 to try to do it. And if you guys are confused on how to program this, you can DM me, Grady, or Daniel. All right, it's 3:40. Does anyone want more time to do this? I think it will be okay. We could just go through a little bit less than anticipated today. Oh, okay. Oh, seems like people are pouring in. All right, we got a lot of answers pouring in. And the good news is all of you guys are right. Or at least the people who have completed so far are all right. So the most general way to do it is, okay, set this up. So the question itself asks for basically printing on a bunch of squares. So, and because for that specific exercise, it had 10 numbers. So, but we want to start at 1. So I saw a lot of you guys caught on and had integer I go start at 1, which is very nice. And most of you guys did I is less than 11. And one person did I is less than or equal to 10. Both of those work. Okay. And then some people did I plus plus. Some people did plus equals 1. Again, they're both okay. And then all you had to do was system out print line I times I. That would be the correct answer. Someone also used math.pow. And also, if you really wanted to produce the exact result that the exercise wanted, you can go to print line and you can just add an empty space after that. And it will print out exactly as the exercise wanted it. There were some very creative ways to do it as well. They decided to take on the challenge. And I'm just going to copy paste one person who did it this way. There were like 2 people who did it, which is they kept track of like the difference and they kept on adding to the difference. Right. So I think they meant to do this. Right. And this works, which is like, you guys are creative. That's good. There you go. See, look, even though this does not involve any multiplication whatsoever. But yeah, I hope this kind of shows that, for loops can be pretty flexible. Okay. I got more answers pouring in. Oh, pursuing for me to check. Okay, we're gonna go ahead and move on back to the slides before we get too sidetracked. Let me see. Where did my slides close? Okay, no, right here. Here we go. All right. Let's see. We've got 17 more minutes. Fortunately, the next ones are a little bit shorter. So let's see. We might be able to get through. We can definitely get through while loops. Okay. So a while loop is a for loop, but you only have an exit conditional, and that's it. Okay. And this exit conditional, you can be comparing strings. You can make it an infinite loop if you want. And there are applications where you want a while loop that runs forever. And also, let me think. You could keep a counter, and you can do some more extra like manipulation or whatnot. But in general, a while loop is a for loop, but kind of stripped down. Okay, so the general format is just while parentheses exit conditional, and you got your body. And while the condition is true, the loop will run, and the condition was always checked before the body is executed. You can see here, this is the for loop but expanded as a while loop. Okay, so integer equals 0 while else less than 5, blah, 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 I++. Okay. And let me think. If you're like doing some sort of code where you don't know how many times you have to run to stop, for example, there is some math, there are some sort of like math algorithms or whatever that if you want to implement into programming, you have to keep running until you meet a certain threshold. For example, that's when a while loop might be useful. But again, while loops are a little bit more situational than for loops. Most of the time you will see for loops, but I would argue while loops are more common in recursion. And there's a special type of do while loops, which I think is especially useful when you have to do like files and whatnot. I'm not totally certain myself actually, but a do while loop means we're going to run this code first, or because remember the while loop, it always checks the exit condition first. Do while will always run the body at least once, and then it will do the conditional. So the process in which it does the conditional is a little bit flipped. Okay, that kind of makes sense. That's a do while loop. All right, you know what? Whiles were short, so let's go ahead and get to arrays. Okay, and arrays is going to be the arrays is probably going to be the first. No, it's still. I think it's still primitive type. Is this Grady and Daniel? Is it a primitive type, or at that point is it not? Do you guys know?
I don't believe.
I think they aren't, right? Because they have methods.
Well,
and whatnot.
actually,
I believe arrays are primitive types, but array lists are
right. Okay.
Except there's some different things. I wouldn't necessarily like it doesn't follow all of the pass by value, pass by reference rules the way an
object does.
An object does.
Right.
So
okay, but I think
I mean not the way an object does, the way a primitive type does.
Right.
So
okay,
just be careful about that.
Yeah, but arrays is going to be our first more or less more complicated data structure. Okay, and arrays are fun. So simply put, an array is a list of elements, a list of things. For example, you have a shopping list. You have 1, 2, 3, 4 stuff that you want to buy, right? That's a list, and you can store that information in an array. And we're gonna, just to be very specific, arrays have a fixed size and length. So once you make the array, you cannot change the size of it. If it's gonna hold 3 elements, it will only hold 3 elements. Okay. And in order to initialize an array, you say the type that the array will hold, the type of value it will hold. In this case, we're only holding integers. Okay. And then you put these square brackets next to it. So we have integer square brackets. If you want to hold a bunch of booleans, boolean square brackets, strings square brackets, etc., etc. Okay. And then if you want to initialize an array with contents, like 1, 2, 3, you use curly brackets and you use commas to separate them. Okay. And if you want to initialize an array with a certain size without any content, you just say new integer 2. And the difference between these two, the difference in similarities is they both create an array with a size of 3 elements. Okay. Oh, actually, sorry. The first one creates a size of 3 elements. The second one creates a size of 2 elements. So they both already have a fixed size. Okay. But this one obviously already has variables. So if you say array, if you select the first element, you're going to get 1. If you select the second one, you're going to get 2. But if you directly try to get something from array 2, you're just going to get null, which means there's nothing here. Okay. So to start out the print line array 0, that's going to get, remember? Oh, sorry. I'm slowing up my speech here. In order to select, in order to get a value from an array, you have to say the array variable name, square brackets, and an index of the element that you're retrieving. Okay. And so if we say array square bracket 0, we're going to be getting the first element of the array. And this is pointing to, don't have my pointer? There you go, I have a pointer. This is going to point to this array, 1, 2, 3. The first element is 1, which is at index 0. So we're going to get the value 1. So this line is going to print out 1. So what do you guys think this line is going to print out? Where we say send out the print line array 1. like I say to the chat. Right, that's right, you get 2. And what about this next line, array 2, 0? Remember, array 2 is the one with no contents. What are we going to get from it? Does anyone know? Right, now, yeah, that's right. It's null or 0. And technically, all of you guys are right because you guys said nothing because we literally get nothing. But if you try to print it out, the Java would just go in and say null, null. Okay. And then we're going to talk a little bit about properties. So I think array is an object, guys. I'm pretty sure it is an object. And this is like, you can have like variables or values attached. Oh, it's just actually 0, Grady. Oh, okay. Well, thank you for correcting this time.
If it's an object type that's anything other than a string, then it'll be null, I'm pretty sure.
Okay. Okay, so primitives. Okay, gotcha. That makes sense. All right. I hope that clears a few things up. Sorry, this is okay. But either way, as we go ahead and do more stuff and we start using more objects and whatnot, it's very common to have an object have properties or variables attached to it. In this case, array.length is an integer, and I hope it's self-explanatory. Array.length is the size of the array or the length of the array. Okay, so for example, in array we have three numbers inside it, right? So the length is going to be 3. Array 2 has a size of 2, so the length is going to be 2. I hope that makes sense. So it's not out print line array.length, it's just going to spit out 2. Sorry, 3. And if you want to change the values inside an array, you do the same syntax as getting a value from the array, and then you do the equal sign, blah blah blah. So this is kind of like the declaration of a variable, except we're pointing directly into an element inside the array. I hope that all makes sense. Okay, so just a really quick recap: arrays, they always have a fixed size. Okay, they're either going to have a size of 4 or it has a size of 5. It can't grow or shrink. And it starts counting from 0. So the 0th element, the 0 index, is actually the first item. And the first index, the index 1 is actually the second item. And arrays have properties to it. And the most commonly used one is probably array.length. Okay, it gives you the size of the array. And we're going to talk a little bit more about more complex data structures. But again, as we go more and more complicated, this stuff is going to get more and more situational. But if you want to represent a coordinate system or something like that, or a matrix to do math, just for a 2-dimensional array is helpful. And right now on your screen, there's a lot of curly brackets and square brackets, but we say integer square bracket of a square bracket. And let's break this down really quickly. In the previous slide, we made every single element is just one single number, so it's just integer, and then we do brackets to say that it's an array. Here, every single element is an array that holds integers. Okay, so when we say this, we're making an integer that an array of integers, and then we're making an array of integers. I hope that makes sense. And we say new int. This is the size of the inner one. This is the size of the outside one. Okay, so it'll generate with 0, 0, 0, 0, 0, 0. And then to assign stuff, you get the outside array first. You pick the outside one. So 1 refers to the second one. And then 1 refers to the second one inside the second one. Okay. And you can represent it as a table. Okay. I hope that sort of makes sense. I don't. 3-dimensional arrays are very confusing when you see it in code. Okay, but think of it as rows and columns. All right. If you think of it as a table, it'll make more sense. All right. Should we? Got 6 minutes. Okay, I think we can. Once I got a class, if I have a classwork assignment, I think it'll be better to do the classwork because I don't want to stuff you guys with too much stuff to do. Arrays. Oh yeah, I have a exercise for arrays. Okay. All right, we're just gonna do this, and then we're gonna end the lesson today because I don't want to bombard you all with information. So this one's a short, kind of like a short answer type question. We're gonna, let's do this together as a class. All right, I'm gonna quickly sign into my. Okay. Remember my own password. Okay. No, but it said the answers. Okay, that's stupid. All right. So let's go ahead and break down this code real quick. So it's asking what are the values of the elements in the array numbers after the following code is executed. Okay. And then here we have an array of integers, right? And we have numbers 10, 20, 30, 40, etc. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in this array, right? And here it's starting, we have a loop that's going from 0 to 9. So it's going to run 8 times. It's going to run 9 times. Okay. And then it's going to select a number at that index and it's going to assign it to the next number. Okay. So let's go and do this as a class. What do you guys think numbers, let's do the first one together with me. All right. So number 0, what is the value of number 0? All right, let's think about this. The first loop, right? We're changing numbers from square bracket 0, right? And we're assigning to the next one. So, and numbers 1 is equal to 20. It's going to say 20. Okay. And now 1, now numbers 1, that's going back to the loop. Okay. We're going to assigning number 1 to 2. So this is going to be 30. So what do you guys think numbers 2 is going to be? Let's go rapid fire. Let's go into chat. What do you guys think numbers 2 is going to be? Right, good. 40. What about 3? 50. Okay. What about 4? 60. Okay. 5. 70. 6. No, it's not 90. 80. Okay, good. What about the next one? 90. Wait, did I get ahead of myself? Okay. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. What about 8? What about number 9? Okay, I wasn't saying 100. Okay, good. So the reason, first of all, we don't have another number after 100. So even if we try to assign it to the next one, the code will actually break. It'll throw an error. And also the loop itself actually stops itself before getting to the last one. So we get to 100. We submit.
Samuel?
Ta-da. Yes, great.
Never mind.
All right. Okay. So it is 3:58 or 2 minutes off the mark. So if anyone has any questions, now's the time to ask them. But otherwise, we're gonna go ahead and end the lesson here today. I posted the homework, and I'm gonna make a smaller new system. Okay. If you guys want to do the homework and you guys completed it, and it's one where practice it doesn't automatically tell you where it is. For example, if you're doing one of the optional assignments, you can DM the code to one of the senior members, Daniel, Grady, me, and we can go ahead and check your code for you. And I think that's it. We got through all the topics we wanted to go through today. So yeah, I think today was good. Again, I'll be here for 2 more minutes, or all of us are going to be here for 2 more minutes. But otherwise, lesson is adjourned. You guys are free to go.